Okay, so now I'm going to talk about a Mips instruction to add two numbers. So in your C or high level programming language, suppose if you want to add two numbers that are in the variables a and b, you'd write something like this in your high level language. Well, in Mips, an equivalent code for this operation would be something like this: add $17, $18, and $19. So this dollar symbol indicates a register. So I've already talked about Mips having 32 registers. Right. So suppose this register is known as $17, this one $18, and this one $19. So the first register starts from $0, and therefore to have 32 registers, your last register must have a number of 31, since all of these are sequentially numbered. So basically, suppose if the value of A is 5 and the value of B is 7, you'd have the result 12 in C, right? So in Mips, as I previously said, you have to load these values from the register to your ALU. Suppose your register, so which of this is A, which is B, and which is C? Well, Mips follows this format: add rs, add rd, rs, rt. So what do I mean by this? Well, rd stands for destination register. Similarly, rs and rt stands for source registers. So here we need to have the values of 5 and 7 in our source registers. So your source registers are the registers that hold value which get operated on. So suppose $18 had the value of 5, $19 had the value of 7. So we talked about ALU before. So that was a pretty horrible attempt at drawing an ALU. So still not much better, but anyway, we'll go with this. So suppose your ALU would be fed values from these two registers, and it would store the value here in 17, right? So you'd have the value 5 fed here, and you'd have the value 7 fed here, and your output 12 would be stored in $17 register. So this is a typical how a typical add operation in Mips looks like, and this instruction has a specific format, and that format is called the R format instruction. So in Mips, that is what the format for an R format instruction looks like. Okay, so by format I mean this one, where you have 1, 2, and 3 registers, where the first register is the destination register, the second register is the first source register, and the third register is the second source register. So similarly, if I now want to suppose write an instruction like this, suppose C equals A minus B. Well, the translation for this high level programming language to Mips assembly language would be sub dollar. Again, I'm going to assume that I want to store the result in $17, and $18 contains the value of A, and $19 contains the value of B. So assuming that the value of A is in here, the value of B is in here, the translation for this code is this, that store the value of $18 minus $19 to $17, and by dollar, as I mentioned previously, I'm talking about registers. So again, the format would be like this. This is the destination register, this is the source register, and this is the second source register. So in other words, RD equals RS minus RT here. So this is basically what the R format instruction looks like. So add and sub, these are known as arithmetic instructions, right? And I said that these are R-type instructions. So now let's take a look at some logical instructions such as and, or. So both these sets of instructions, arithmetic and logical instructions that correspond to add, sub, and, or, are R-type instructions. And since they're R-type, they all have the same instruction format. So suppose if you wanted to add two numbers, suppose one number is in register 18 and the other number is in register 19, your add instruction would have the exact look and feel of the add or sub instruction that we learned previously here. So basically, again, this would be your destination register, this is the first source, and this is the second source register. So these two numbers are going to be ANDed, and the result is going to be stored here. So I hope you're all familiar with an AND operation. So in AND operation, suppose if I want to draw a truth table here for AND operation, so if you have two numbers where both the bits are zeros, or if you have two bits and you want to add them and both of them are 0, your result is going to be 0 as well. So only when, if you want to add two numbers and all those numbers have bits that are 1, you're going to have a 1 as a result. Otherwise, for every other case, your result is going to be 0. So that is what an AND operation looks like. So suppose for OR, you'd have the exact same format as the AND operation, which had the exact same format of add or sub operation. So this was AND, and I hope you're all aware of what an OR operation looks like. So for OR operation, only when you have both the bits or both the numbers as zeros, you're going to have your result as a 0. Otherwise, for every other case, you're going to have a 1. And that is basically what the truth table for an OR operation looks like. So in short, with Mips, we learned about the R instruction type here, and this instruction includes operations such as AND, sub, and OR. So the important thing to note here is that our instructions involve the use of 3 registers. So at any time you see 3 registers being put to use, you can assume that it's an R-type instruction.